Okay, so today we are talking about fundamentals review day 3. Okay? And on day 3, we're going to look at combining like terms and reducing rational expressions. Okay? And so things to remember when you're combining like terms is to combine like terms, you have to have like terms, right? Okay? Constants are always like terms. And then like terms must have the same variable with the same number of exponents. Okay? And then things to remember when reducing rational expressions. To reduce a rational expression, you must have a common factor in all terms. Terms are separated by plus and minus signs. So, when looking at these first couple examples here, okay, we just want to combine like terms, okay? So I'm going to use different colors here to associate which are like terms and which are not, okay? So, when we look at number 1 here, it looks like we've got this negative 3x and 15x, and then this negative 9, okay? Well, the negative 3x and the 15x are like terms. So I'm going to combine them. Negative 3 plus 15 gives you 12x. And then there's nothing else we can do to that negative 9, so we just bring that negative 9 down. Okay? All right, number 2, same thing here. We'll use a couple different colors. Okay? We've got 4x squared, negative 2x squared are like terms. Why are they like terms? Because they both are x to the second power there. Okay, then we have just this x by itself, and this 2 as well. Those have their own terms. So when I write my answer out here, I'm going to combine whatever I have that are like. So in this case, 4x squared minus 2x squared, that's going to leave you with 2x squared, okay, plus the x plus 2. Right? And that is my final answer. Okay? All right, number 3 here. First thing we need to do before we even think about like terms is that we've got this minus sign here in front of a parentheses. We need to distribute that minus sign through. And so when I do that, I'm going to be left with this. I'm going to have now 5x plus 4. Minus sign to the 5x now gives me a negative 5x. And then minus sign to the 3 now gives me a negative 3. Okay? And so when we talk about like terms, now we've got this 5x, negative 5x. Okay? And then we've got 4 and negative 3. Okay? 4 and negative 3. So let's combine those like terms first here. Okay? With the variables. So we've got 5x minus 5x. That's going to give me 0, which we do not have to write that. Okay? And then we've got now 4 minus 3, which is 1. And there you go, that's your final answer. Okay. All right, number 4. Okay, looks a lot like number 3. We still will go over though, just to make sure. So we've got this minus sign here. Again, recall it distributes to the values inside the parentheses it's in front of. And so you're going to have something that looks like this. You're going to have 3x to the third minus 2x. Minus 2x plus 3x to the third, okay? And now let's underline our like terms. So anything with x to the third, so we've got 2 3x's to the third there, and that's going to give you, when you add those together, it's going to give you 6x to the third. Again, guys, and I went over this. I went over this, probably surpassed it, or went over it without saying. we always want to write our terms in descending order, okay? Highest exponents to lower exponents then to constants, okay? And then we've got a couple other like terms right here. We've got the negative 2x and the negative 2x, and that's going to leave you with a negative 4x. And there you go, that's your answer. So 6x to the third minus 4x. Okay. Number 5 here, again, same thing. We've got a minus sign in between this parentheses here. I hope you guys are seeing the theme. Got to be good at distributing minuses or any values out in front of a parentheses. Okay, so in this case here, this is what we have first. We have now 8x to the third minus 6 plus 3x to the fourth minus x to the fourth. Negative times a negative gives you a positive, 7x to the third. Negative times a negative gives you a positive 3. Okay? Now let's underline our like terms here. Looks like we're going to have a couple. Okay, so do I have any other x to the third? Just do. So I have 8x to the third. I have 7x to the third. Okay? I've got 3x to the fourth, negative x to the fourth, so 3, that's like having a 1 in front, guys. That's a 1x to the fourth there. So 3 minus 1 is going to give me 2x to the fourth. Actually, let's write the answer down here. So 2x to the fourth, okay? 8x to the third plus 7x to the third, okay? 8 plus 7 is going to give you 15. X to the third, okay? And then it looks like we just have constants left. So we've got this negative 6 and this positive 3. Negative 6 plus 3 is going to give you a negative 3. And therefore, that is our final answer. Okay? All right, last but not least here, let's look at number 6. Okay, let's look at number 6. All right, a lot going on here, okay? Just really pay attention here, okay? Really pay attention. So let's look at if we have any like terms. I'll use the color red to see the first. So we've got 3x y squared. So do I have any other ones where I've got 3x y squared? I've got x squared here, so no. I've got x here, so no. I've just got y squared here, no. I've got yx, no. I've got y squared, x, yes, right here. So this and this are like terms. It doesn't matter the order, guys, of the x and the y squared. Okay, it doesn't matter the order. All right. And so let's go ahead. Let's combine those. And so when we do that, we're going to be left with now 3 plus 2. So we're going to have 5x y squared. Okay. Let's see if we have anything else here. I've got 4x squared y. Just x there, no. Just y squared there, no. And then just yx, so no. I've got 5x here, but I need a y. I've got nothing to do with the y's and all that. So yeah, it doesn't look like I have anything else. And so then my final answer is just going to be this, guys. It's just going to be 5x y squared, 4x squared y plus 5x minus 7 y squared plus 10 yx. And so yes, I know that's confusing, but again, all we're doing here is we're just combining like terms. We're just combining like terms. Okay? I apologize for the bell. Okay? And so that's our section on combining like terms. Okay? Give me a minute now. I'm going to scroll up and we're going to talk about simplifying rational functions. All right, so to simplify rational functions, there's different measures we have to take. Some problems are different from the others, okay? So this first one here, I call it unique because in this first one here, we just have one term over one term, or what we call a monomial, okay? It's a type of polynomial, right? Okay? And so when you have this one unique scenario, it can look like this. You can write it out, okay? To look like this. So 6x to the third, we can write as 6 times x times x times x all over 2 times x. Okay? So what I'm going to do is now I'm going to simplify. Well, what is 6 over 2? 3, right? I've got 1x here, 1x in the numerator, 1 in the denominator. I can take 1 away from each. And what's left over? 2x's, so x squared. And there's your final answer. Now, in most cases, guys, we are going to have to factor to simplify, okay? So in most cases, we're going to have to factor to simplify. Now, in this case here, it looks like it's already been done for us, all right? So since we were able to do some sort of thing where we factored this 2 out, we can now simplify. So the only thing I ask myself is well, we're not going to do anything with anything inside the parentheses here. Okay, that's a binomial. Okay, that's a binomial that has to have the exact binomial in the denominator to even think about simplifying there. But what I see there here is I've got a monomial times a binomial here. This 2, this individual number, that monomial, over another monomial. So what I can do is I say, okay, what is 2 over 10 equal to? Well, 2 over 10 simplifies to be 1 over 5, and so then your final answer is just this. It's just x plus 3 to the second power. Sorry, that was a terrible 5. Over 5. Okay? Now, sometimes, okay, people are really enticed and they see something like this and they say, oh yeah, I can simplify this. I can do 2, 4. No, don't do that. Don't do that. You can't do that. Here's the reason why, okay? Again, we have what we call a binomial here, okay? 2 terms, x plus 4, okay? That is 2 terms over 1 term of monomial, okay? Cannot simplify. Okay, cannot simplify that problem there. All right, sometimes when I look at this first, and just like number 3, we've got a now binomial over a monomial, okay? Now, in number 3, though, we couldn't factor anything. There's nothing we could do to the numerator there. So, what's going to happen here in number 4 is that, yes, we will be able to factor by taking out a GCF. So I want you to recall how to do that, and we'll get into this more on Thursday, okay? You can take, when you take a 2 out, you're taking that entire expression in the numerator there, and you're dividing everything by 2. And so when you do that, you're going to write it like this. It's going to be 2 times, now, or actually, how do I want to do it? Yeah, let's do that. So when you factor out that 2 there, you're dividing everything by 2. Okay, dividing everything by 2. And I don't know if you guys can see that, so I don't know if that's a good call. Well, okay, so I'll do it over here. So when I take a 2 out, guys, it's going to look like this. I'm taking that whole expression, that 2x squared plus 6, and I'm dividing everything by 2. So then in the numerator now it looks like this. The 2 is on the outside, and you're going to be left with 2 divided by 2, x squared, 6 divided by 2, 3. So now my new problem looks like this, guys. I've got now 2 times x squared plus 3 all over 8x. Okay? And now ask yourself again, this looks a lot like number 2. Okay, this looks like a lot like number 2, where now, because we factored something out, we've got a monomial times a binomial over a monomial. So because they are both monomials, we can go ahead and we can simplify them if possible. And again, I ask myself, okay, 2 over 8, what is 2 over 8 equal to? 1 over 4. And so then when I write this final answer, then I'm going to be left with this. I'm going to be left with x squared plus 3 all over 4x. Okay? All right, let's look at number 5. Okay, let's look at number 5. So number 5 here, we've got a now binomial over a trinomial. Okay? Now, whenever I see a trinomial, I think automatically star method. Okay, star method. Again, we will go over this more in detail on Thursday, but again, here's how you do star method. We draw our star, okay? And so we take the first coefficient times the last coefficient up here. So what is 1 times a negative 2? Negative 2. We take the middle coefficient next to the x and we write it down here. So that coefficient there, the number is 4. And then right here goes the coefficient next to the x squared. So in this case, we're going to write it as 1 and 1. And now how do I go about finding these two values here? Well, I'm looking for two numbers that multiply to give me a negative 2 that add to equal 4 then. So two numbers that multiply to give me a negative 2 that add to equal 4. So negative 2 times 1 gives me a negative 2, but does negative 2 plus 1 though give you a 4? No, it doesn't. Okay? So then what this is telling me is, guys, is that this right here cannot factor. So then this right here, because of that, cannot simplify. Okay, and that can happen, guys. It says if possible, if possible. Okay, so there are problems there where it cannot. Again, why could it not simplify? Why could it not simplify? Because we could not factor the denominator there. And then that means you've got a binomial over a trinomial, which means there's nothing going there. Okay? All right, this last one here, this kind of has it all. Okay, so if we can do everything in here, then we are good to go. Okay, so for the numerator, I've got 3x minus 9. Okay, what I notice is that the 3 and the 9 both have a 3 in common, so I'm going to take a GCF of a 3 out. And so when I do that, it's going to leave me with this. I'm going to have 3 outside the parentheses, and then I'm going to have x minus 3. So that's n for numerator, okay? Let's look at the denominator. Okay? The denominator here, I've got a trinomial, so I'm automatically thinking star method. So we're going to have x squared plus 6x minus 27. Okay? We're going to start the whole process here. Okay, first coefficient times last, so 1 times negative 27 is a negative 27. Middle coefficient next to the x goes down here. And then your first coefficient goes here, 1 and 1. And so then I need two numbers that multiply to give me a negative 27 that adds to give me a positive 6. Okay, and so what those two are then is 9 and negative 3. 9 and negative 3. So 9 times negative 3 gives me that negative 27. 9 minus 3, positive 6. Okay? And so what does this then factor down into? Well, it factors down into something like this. What is 9 over 1? X plus 9. What is negative 3 over 1? X minus 3. Sorry, let me run back real quick and get my computer. Okay, sorry about that. And so that's how you factor that down. All right? So you just literally simplify the fraction there. 9 over 1, 9. Negative 3 over 1, negative 3. And so you've got x plus 9, x minus 3. All right, so let's then bring it all back here and let's write out what we have. So let's write out our reduced numerator. So in the numerator, we've got 3 over x minus 3. All over, what do we factor down the denominator to? We've got x plus 9 times x minus 3. Now, before, what was it? What problem was it? Right here, x plus 3, or the x plus 4. We couldn't simplify anything because we didn't have the exact same binomial. But what do you notice here now between these two binomials? They're the exact same. And so what that means then is that I can go ahead and I can simplify those. And so then my final answer is just going to be 3 over x plus 9. 3 over x plus 9. And again, why can I not simplify this? Okay, why can I simplify this? Monomial over binomial. That plus sign attaches those two together. So we have one term over two terms. Therefore, cannot simplify it. Okay? And that's it. So a little bit longer lesson today, okay? But that should help you guys get through that. And what we will do tomorrow after we go over the video is I will take questions during our live period. And that'll be it. All right, thanks guys. See you in class tomorrow.